All right, we're going to solve a multivariable equation, more than two variables, which means you have to solve completely. Most of the time, you're going to have three equations with three unknowns. We've got an x, y, and a z there. And what's nice about this first one we're doing is z is already 2. We've already solved. They're basically giving you the fact that z is 2 in that formula. So anywhere there's a z, you can put a 2 in that place. And so if we just work up one equation here, you'd have y plus 3 times 2 equals 5. And so that's y plus 6 equals 5. And you subtract that 6 over, and you already know that y is equal to -1. And so we've already got two of our answers. We've got z is 2, we've got y is -1. And so now you can plug into that top equation. So x minus 2 times -1 plus 3 times 2 equals 9. And so you solve that, and you've got x plus 2 plus 6 equals 9. And 6 and 2 is 8, so x plus 8 equals 9. Just combining like terms, subtract the 8 over, and x would be 1. And so we've got our three answers here. So we've got z is 2, we've got y is -1, we've got x is 1. And so we typically write these as what's like an ordered pair, but we've got three dimensions now. And so we've got x, -1, and 2. And so that's just, x, y, z. And what's cool is we can go ahead and use GeoGebra to visualize this for us. And so if you look at this thing, let's see if I can find one here. Yep, there it is. And so this is GeoGebra. You can just Google it. It's free. It's totally free. Very powerful calculator. But you hit this 3D calculator. There's all different types, but we're just going to focus on the 3D. And so when you click on that, and I'll give it a second to load, you have some algebra over here. And then you have this three-dimensional space that it'll graph for you. And so I've already got this thing graphed, and here it is. And you can see my three equations that I typed in, and I colored them, so green, blue, red. And you can just drag this around. The gray plane is your XY plane. You could take that out if you wanted to. And what's kind of neat about this is you can go into the tools, you can intersect two surfaces. So notice when I hit this, I hover over where the pink and the green intersect, it creates a line, so I'll put that in there. I hover over the blue and the red there, or blue and the pink, and it creates another line where those two planes intersect. And then you can stick a point where those two lines intersect. And if you look back here, and if you look back here, and there's our intersection, 1, -1, 2. And so GeoGebra will find the answer for you. But it is kind of neat to see this. And you could see the same thing in your very room. You look in the upper right corner, or upper left corner, whatever. You see where their walls intersect. And that's kind of what this is like. It'd be a pretty funky house to have those kind of angles. It'd be more like a fun house. But what's kind of neat too is that 1, -1, 2, you can see that. So if you look from above, there's our 1 right, 1 down for 1, -1, and then it's 2 out towards us. And so if you flip that up, indeed it's 2 going up. And so that's just a way to represent it in 3 dimensions. And so let's look at another one of these problems. So next problem, problem 2. So similarly, and what I encourage you to do is to stop the video and see if you can figure it out on your own. But I'm just going to go ahead and solve it. And so what's nice is we need to get it like that last problem where you just have one variable by itself. And it doesn't matter which equation or which variable you eliminate. What's nice is, you look for patterns here, and you notice the second one is missing the z. There's a 0 there for the z. plus 0. And so we've already got it down to two variables. So what I'm going to do then is leverage the top equation and the bottom equation to eliminate two variables. And so what would be nice is to eliminate the z here. So then we've got just x and y. So I'm going to eliminate that z and that z. We've got a 5 and a 3. So 15, if one was a positive 15 and one was a negative 15, we'd get this thing handled. So that means what I'm going to do here, I'm going to multiply this whole equation by 5, and I'm going to multiply this whole equation by negative 3. And what that'll do is allow us to eliminate the z. So on top, you'd have 5x minus 10y plus 15z equals 45. On the bottom equation, you'd have negative 6x plus 15y minus 15z equals, and then 17 times 3 is negative 51. And then you add those two together because the 15z's would cancel. And, notice 15 minus 15 is 0. Negative 10 plus 5 is 5y. 5x minus 6x is negative 1x. And then we are equal to 45 minus 51 is negative 6. So we've eliminated all the z's in all three equations. Well, not all three, but we've kind of leveraged those two equations to get us down to this one here without a z in it. And so what's kind of cool is we can bring down that other equation, which was negative x plus 3y equals negative 4. And we want to eliminate a variable here. And so in this case, probably what would be easier would be to eliminate the x. So I'm just going to multiply this bottom equation by a negative 1. So if you do that, this becomes positive, this becomes negative, this becomes positive. So it just changes all your signs. And now when you add down, the x's cancel. And so you'd have 5y minus 3z, which is, or 3y, negative 3y, which is 2y, and negative 6 plus 4 is negative 2. And so y would have to be negative 1. So we have one of our answers. So now we can just plug that in to either of these two formulas, or I would just go with the original. So that negative x plus 3 times negative 1 equals negative 4, that middle equation. So you'd have negative x minus 3 equals negative 4. So negative x, you add the 3 over. Negative x equals negative 1, and x would be positive 1. So we've got two of our answers now. And what you can do then is plug the x and the y into one of the others, just like what we did on the last problem. So that would be, I'm going to plug it into the top equation. So that would be 1 instead of an x, minus 2 times negative 1, plus 3z, and I have to squeeze it in here, equals 9. And so that would be 1 plus 2 plus 3z equals 9. That'd be 3 plus 3z equals 9. Subtract that 3 over. And 3z equals 6. So that means z is 2. And so we have our solution, which is 1, negative 1, and 2. And again, I'm going to go into GeoGebra and see where that, make sure that's right. And I have it graphed here. And so here's my three equations right there. You can kind of float it around here just to look at it. And it might help if I do that so we can see it better. And I could get rid of the algebra. And again, you go into your tools. Hello. Okay. Sorry, my audio went out. But anyway, when you plug these in, you would have you'd have these two lines that you can see where they meet, and I'll just throw those in so you can see it. And then notice again that there's my A, which is 1, negative 1, 2. And we could go in and see that in the space. But there's where my three planes intersect. And again, that gray plane is the XY plane, basically kind of like the origin. And so there we go. We're getting there, getting this all figured out. All right, so next problem. So here we have a little bit of an issue because we have three, nothing's eliminated, and so we're going to go ahead and eliminate a variable. Now you can pick anything you want as long as you stick with it through the whole thing. So I'm going to deal with the top two equations, and I'm going to eliminate x all the way down. So if I multiply this top equation by 2, well, in fact, negative 2, and add it to the bottom, so you'd have negative 2x plus 6y minus 2z equals negative 2. And your middle equation, I'm just going to leave it exactly like it is, minus 2z equals 2. And then you add down, you would have 5y minus 4z equals 0, because negative 2 plus 2 is 0. And then you could do the same with your bottom two equations. And so what we're going to have to do here is multiply this one by negative 2 and leave the middle one the same. So you'd have 2x minus y minus 2z equals 2. You're going to have negative 2x minus 4y plus 6z equals 2. You add down, and you would have negative 5y plus 4z equals 4. Okay, and so we have these two equations. We're down to y's and z's. Here's my two equations and two unknowns. So I'm going to stick those together. And so we've got 5y minus 4z equals 0. We've got negative 5y plus 4z equals 4. And we could already add these equations down. And what you'd notice is the y's and the z's cancel. They'd all be 0. So we'd have 0 equals 4. Which in that case, 0 can't be 4. So what we have here is a no solution situation. And so sometimes you don't get an answer. So somewhere in here we got planes not intersecting. So let's look through this in GeoGebra. And here's my three equations. Here we have it. Let's see if I can, oh yeah. And what's kind of cool here, and again, that gray plane is the XY plane. Our three equations are the purple, pink, and green. And what you notice is we've got these parallel lines where these two lines will never meet. And so we've got a situation where the three planes do not intersect. All three of them do not intersect. And now they'll intersect, but they don't intersect on the same plane. So if you notice, eventually the green and the purple one intersect down below, but the three of them, you've got a set of parallel lines so that there's no way they intersect together, so that all three intersect. And you can look around as much as you want. You'll never find a point on one of the planes where all three planes intersect. So we don't have a corner. Basically we have two parallel walls, like a north wall and a south wall or something like that in a house. Those don't intersect, hopefully. So there we go. So we've shown that where they don't intersect. Okay, so let's hit one more problem. Okay, so let's again, pause the video, see if you can solve this thing. And here we go. So let's, in this case, let's go ahead and, I don't know, let's eliminate the x. So I'm gonna do these two equations and see if I can't get that x eliminated. So all we got to do is add those together. It'll add a z in, but that's okay. So x minus x is 0. Y plus 2y is 3y. Negative 3z plus 0 here is negative 3z. And negative 1 plus 1 is 0. So that stays like it is. And then we'd have y minus z equals 0. That's this middle equation. And we need to match up our y's. And you'll notice here we're going to get something similar happening, but it'll be slightly different. So we're going to eliminate the y's. So we're going to multiply this bottom equation by negative 3. And you'd have negative 3y minus 3z equals 0, because 3 times 0 is 0. And if you add down, you'll notice what happens is you get 0 equals 0, because 3z and 3z cancel, 3y and 3y cancel. 0 and 0 is still 0. So 0 equals 0. So this would be, you'd have an infinite amount of solutions in this case. And so let's look and see what that looks like in GeoGebra. And so if you look in GeoGebra for that one, here's what we have. Let me get rid of this, because this is kind of a fun one. So it looks like they're all intersecting. Well, if you line it up just right, you line it up like the shaft of an arrow. So what you have here, and let me put in that line. Let's intersect these. Let me try and get it. There we go. And so now when we go in to look at this, that shaft of that arrow, those three planes exactly meet on, they all meet on the same line. So you're infinite, you have an infinite number of solutions for those three planes along that line. And again, you have to imagine an arrow. So we've got this, arrow, and you have these shafts coming off of it. So the fletchings of an arrow would be like your planes, and they're all meeting on the shaft. And so that's what's happening in this situation. So we have an infinite number of solutions along the arrow, basically. And so there's some basic stuff for 3 equations, 3 unknowns. Hope this helps. See you next time.